Chapter 5, Section 4.3 and 4.4, which are properties of logarithms. In this section, we'll discuss some of the properties of logs, how to expand them, how to condense them, how to change them into exponential form, how to take a exponential and change it back into a log, and a whole plethora of stuff. But let's look at the definition of a log. For b is greater than 0 and b can't be equal to 1, the base b log of x, written log base b of x, is the exponent to which b must be raised to in order to yield x. Well, that really doesn't make a lot of sense because that's a mathematical definition, but as we progress through some of these problems, it's going to become evident what that really means, okay, when we're changing things over. I guess the biggest thing you take from this is the base of the log and the base of the exponent or the exponential function or equation are the same. So they're inverses of one another. An exponential undoes a log and log undoes a exponential. So they're kind of like multiplication, division, addition, and subtraction. They're inverse operations. So converting a log to an exponential function and vice versa is given by the second. You can memorize that, but I'll show you a easier way to do that without having to memorize it. But in all of it's based, all of it's based upon the understanding of the base of the log b is the base of the exponential, and we'll do what's called a backwards c, but we'll kind of do some more stuff later on that. But just kind of wanted to get you exposed to that. And then some useful log properties. If you have the base and the of, if they are the same, then it's just 1. It equals 1. Okay. If you're taking log base b of 1, you take the log of 1, no matter what the base is, the result's always going to be 0. And then if you take the log base b of b raised to some power, then it's just going to be that power. Another one that we can kind of talk about here is called a common base. Oh, I shouldn't say common base. It's a common log. Okay, it's a log with no base. The base is understood to be 10. So on your calculator, when you're doing log of 2, really what you're doing is it's understood to be that you're looking at a common log, a log with no base. Well, it does have a base, it's just not written there. It's understood to be a 10, and it's called a common log. So we'll talk about things like that as well. Properties of logs, and it really goes back to exponents. Properties of exponents can also be applied to properties of logs. A to m times a to n equals a to the m plus n. You can add those exponents. A to the m divided by a to n, you can subtract those, and then a power raised to a power just becomes multiplying. So, and then properties of logs when it comes to expanding and condensing. If you have the log of two things being multiplied, you can separate them with the same base by adding an addition between them. As such, log base b of x times y is equal to log base b of x plus log base b of y. Okay, those are equivalent. And if you have a quotient or division, then it's separated by a subtraction. Power, if you have something like log base b of x raised to the k, that k can move to the front as it's being shown right here. It's called the power property of logs. Okay, so anything that is set in front of a log really goes back to right there, to the power of. Okay, so just kind of wanted to go through those. We'll pick up some more and kind of talk more about them as we progress through the problems in this section. Compound interest is another equation that we'll look at, and we'll look at some word problems in telling that. But we'll look at the n, and the n is the number of times it's compounded, and we may look at it in terms of monthly, yearly, daily, weekly, so forth. So that n could mean different things, right? So forth, you know, the n would be whatever the scenario in. You know, if it said quarterly or just whatever it says, you know, that n is going to represent a number and it's going to be in there. So we'll come back and visit that, but just want to kind of bring your attention to that. You should have been exposed to this compound interest formula along your way, but we'll delve into that more. All right, so let's kind of look at some problems and simplify by filling in the correct exponent. And if we're looking at this, you know, if you're multiplying two bases, two things that have the same base, then you add their exponent. So that's really like 10 to the 5 plus 7, so that would be a 12 up here. Okay. And if you compute log 10 to the 5th, now remember that there's no base on this, right? Because it's a common log. And you remember when we done a property that said if the base and the of are the same, then it's just the power. It's this log. Okay. So that would be just 5. And the same thing here. If it's log 10 of 7, the base is understood to be a 10 down here because it's a common log. So that's really 7. And then if we're looking at something like this, then actually we're looking at log of 10 to the 12th, right? Okay, so how are they related? They're related by properties because they're inverses of one another. Okay, one more and then we'll be done with part 1, and you'll have enough to do to kind of chew on that and before you begin part 2. Combine into one log and simplify. Assume all expressions are defined, meaning they exist. Okay, so if we're going to do this, we have two logs, same basis, separated by subtraction. So really that's log base b of 15 over 3. Ladies and gentlemen, that's nothing more. 15 over 3 is nothing more than log base b of 5. Okay, and if we do this, log 7 times log 2 of x plus 4 times log 2 of r is equal to, well, we said if there's anything out in front of the log, then that's really the exponent. So let me kind of do this. Now these are separated by an addition, so that means that they're multiplied, so that's really x to the 7th, y to the 4th. It'd be its answer. Okay, it would become this, and they've already got the first part up there. I just done that wrong. I put a y and it's an r. I just caught it. So let me go fix it. X to the 7th, r to the 4th. There you go. I don't know why I put y. All right, so this concludes Chapter 5, Section 4.3 and 4.4, Part 1 video.